Hi everyone. Today I want to talk about impermanent loss, and specifically I want to show you how you can create your own spreadsheet to do different kinds of calculations and make up your mind about when you're providing liquidity, if you want to risk taking the impermanent loss or not. So this tutorial will assume that you know about DeFi, that you know about decentralized exchanges, automated market makers, and liquidity provision. But just very roughly, for those that still want to keep up, even though you don't know about all of these topics, when you're providing liquidity, one of the most important concerns for you is impermanent loss. And impermanent loss basically means that you could have a scenario where you hold two tokens, let's say the token foo and a few US dollars, and you would just hold them. And they would change in price over time. Now, the question is, if you are a liquidity provider where you are exposed to a changing ratio and the different amount of tokens that you can take out later from the liquidity, how do these different scenarios compare? How does just holding compare versus providing liquidity? And there is this phenomenon in providing liquidity called impermanent loss, where you might get less out than if you were just holding the tokens. This is just a natural phenomenon. This is part of being the counterparty for the trader as a liquidity provider. But what we're going to do is we're going to take a look at how can you create a spreadsheet that tells you how big impermanent loss could be for your specific use case. And then we are going to look at how would the same position develop if you were just holding both tokens, if you would be holding one token or the other token. And I think it works pretty quickly, so let me go through it briefly. So we're going to make an assumption. So our base currency in which we're doing our calculation is foo. We can also take Bitcoin or Ethereum or whatever. And we have a quote currency. This is the other currency. And we're going to say this is US dollar or any stable coin. Okay, and now we need to flesh out the initial situation. How does the situation look like initially? So you have a position size or position value, let's call it position size, that is $1,000. Let's call it position value. This is $1,000, and then let's assume the initial price. So the base price of foo will be, let's say it's worth $100, and the base price of USD will always be $1. We use this here because in theory you could also use other tokens in this example, but we're starting out with a simple example. Okay, so these are our basic assumptions. Now let's assume you're building this position of $1,000. So how much of each token do you need to fill up liquidity into the liquidity pool? Let's start with the easier one, which is the US dollar in the liquidity you want to have. So this is basically half of the position is in US dollar, half of the position is in liquidity. So we can say that the position value divided by 2, this is the value of the position, and now we are dividing by the denomination. In this case it is 1. So, and this gives you the price in US dollar. And now we want to say how much foo do we have in the liquidity. We know that we need foo worth $500, but how much is it? When we have foo worth $500, we can see that when one foo is worth $100, we will arrive at 5 foo. So now what is the formula? We take the position value, we divide it by 2, and then we divide it by the value of the price of foo. And what do we get? 5. So this is our liquidity position. This is how much tokens we're getting in USD and in foo, and we add it to the liquidity initially. And this will allow us in a few minutes to compare how the position would have developed if we just held the tokens versus a situation where we have provided liquidity and the whole ratio changed. Okay, now here comes the tricky question. How do you know the composition of the liquidity pool in the future when the price changed? So let's say we arrive in the future, and let's say this here was the present, and now we're arriving in the future. So how did the prices in the future change? So let's say the base price of foo, and what is it in the future? Let's say it was $200. Yeah, so it doubled in value. On one foo is now worth $200. So what is the base price of USD? Let's assume it stays the same. So $1 is $1. Okay. Now, tricky question: how much foo do we have in liquidity, and how much dollars do we have in the liquidity? How did the position change over time? You could do some guesswork, but we're going to do the math. It might seem like a little bit of a brain fuck initially. There is a lot of explanation behind it, but let's see how briefly we can get through this. So the basic assumption you're having is that a liquidity pool works under the assumption that x times y is equals k. What does it mean? It means that if you multiply the amount of token 1 and token 2, you will always arrive at a constant value. Or in other words, whatever the composition initially is at the present point in time, so let's say at the present, whatever this value is, the same constant that we arrive here will also be valid in the future. So in other terms, what we can say is that we want to determine k for the present, and k is x times y. So k, this is a number. Yeah, it doesn't express anything. It's not a unit. It is just, it expresses the relationship of the value of foo versus US dollar. And so in the future, k also needs to be satisfied. So in the future also, whatever we get here in these values, whatever there is in the liquidity in foo and USD, together if you multiply it, you need to arrive at a k of 2,500 in this example. Okay, we played it through on Twitter. There is a derivation on how you arrive at this, but I will spare you the derivation. I will just show you what the result is. And so to arrive at the result, what you're basically doing is that you're calculating the ratio of the new tokens here. So this is the first token divided by the second token. This is the ratio that you have. And this ratio now helps us determine x2 and y2. So, and what we're doing here, I'm taking a look at my cheat sheet, is that we're saying we are taking the square root of, just a second. Yeah, so we are taking the square root of k and we divide it by r. Check. Is it correct? And it looks correct to me. So this is how many foo tokens there will be in the future. Okay, and now we do the inverse thing. So to get to the amount of dollars, we take the ratio, or k, multiply it with the ratio and take the square root of that. And it yields an error. Oh, oops. So we take the value of k, times r, square root of that, $700. So you see, if we take out a few of the decimals that we don't need, let's keep 2 decimals here, you see that you're getting 500 foo and $700 US. This looks roughly right. We will make a check in a second, but let's assume 1 foo is now worth more. It makes sense to have less foo in the liquidity pool just because it became worth more. Because when foo goes up in value, more people will come and use their USD, put it in the liquidity pool to take out foo. So they put in USD, they take out foo, which means there is more USD and less foo in the liquidity pool. And we can test it out. We can say this times this, it should be the new K, and this is right. This is 2,500. So our requirement is fulfilled. K is still 2,500, and we know this is a valid representation of the same liquidity pool, just on a different place of the curve. Okay, and now it's very simple. We can determine the position value of this thing. So this is the position value. And what we can do here is very simple. We say the number of foo tokens times the number of the value of foo plus the number of dollars times the value of the dollar. And what we arrive at is a value of 1,414 USD. So, assuming that you initially had a position size of $1,000, at this composition here, and one token, the foo token, went up in value times 2. What you will arrive at is a situation where the value of your position is $1,414. Okay, fair enough. But what does it mean? Was it good? Was it bad? This is where we can compare the situation, what would be the value of our position if we just held. So let's say this is position value if in liquidity. We are expanding this a little bit. And now we say, what is the position value if held, if we just held the tokens? And this is fairly easy. We can just take the past number of tokens we had in 1 times the current value plus the number of tokens previously times the current value, right? So if we just held them, they would be worth what they're worth now. And what we arrive at is $1,500. So if we just held the tokens, our position would now be worth $1,500. So because we provided liquidity, we acted as the counterparty for someone who took the smarter directional trade, and whatever they earned, whatever their additional earning is, we make as a loss. If we would liquidate our position now, we would have made impermanent loss. And this is the loss of the relationship of the two. So what we can say is that the impermanent loss is the relationship of if we're providing liquidity versus if we just held. So we are now basically having, this is a percent, we are now having only 49% of the same value, or in other terms, let me look this up, let me look in my cheat sheet, yes, 1 minus. So in other terms, is it right? Is it right? Yeah, in other terms, we lost 5.7% of our value. This is correct. Yeah, so this is the impermanent loss. We can also play a different example. So let's say, because now we have the formula, so let's say it went times 4. What is the impermanent loss? 20%. Quite substantial. Times 5, 25.46%. So this is how you arrive at the impermanent loss that you're incurring. So the value of your position changed, but this is how much you lost. Yeah? This is the loss you're having. Yep. So this is the basic calculator. This is the basic assumption you can use when you say, I have 2 tokens. And now you can change this. You can say USD is something different. You can say I have bar token or Bitcoin or ETH or Polkadot. Any of these is possible. Then there is another realization that now can set in, and that is the realization, yeah, but maybe you wouldn't have held both tokens. Maybe you would have just held one of the 2 tokens. So you can also talk about this. Position value if just held foo, or position value if just held USD. Okay, so what would your position be worth if you just held one or the other token? And to do this example, we can say that imagine in the original point in time, you were just holding one of the 2 tokens. So let's say originally you were holding $1,000 worth of value, and you were buying foo for $100 per foo. And then what would it be worth now? You multiply it by the worth of what foo is worth now. So imagine you would have bought foo for $1,000. One foo was worth $100. Now it's worth 5 times that value. You would see that your position would be worth $5,000. Okay, what would your position be worth if you just held in USD? So you say the value of the position divided by the original value times the current value, and what do you have? You have a value of $1,000. So where does it leave us? It leaves us at, if you held the losing asset, your position would now be worth less than if you were providing liquidity. But if you bought the winning asset, your position would be worth less than the winning asset. So in a sense, it leaves us with very basic terms, and that is, if you're very certain about the ratio, about the direction between two assets, let's say Bitcoin versus ETH, and you say, I'm certain Bitcoin is going up against ETH, you would just buy Bitcoin. Or if you're certain ETH goes up against Bitcoin, you just hold ETH. If you're not sure, but you trust that both assets will gain in value, you can just say, I'm holding sort of an average between the two. And you can do this by holding liquidity. So you say, I'm not sure if Bitcoin or ETH will perform stronger, but I believe in both of those assets to be valuable and go up in value against the dollar. You can say, I'm holding liquidity, I'm providing liquidity. So I'm not winning by taking a bet in one of the two, but I'm actually betting in the two, and they will go up in value together. Now you have this situation here that if you just held it, you still have the impermanent loss. So why would you even provide liquidity if you could just hold both of the items equally? And this is usually the situation pre-2020. So there wasn't too much sense in providing liquidity, because if you just held both items, both assets, you might have been in a better situation. This all changed with the advent of liquidity mining. And with liquidity mining, suddenly it was not only you get this $2,236, but plus rewards. So plus rewards, it's not a formula. At some point in time, it became clear that people will not be providing liquidity because they are losing to impermanent loss. And so what they decided to do, what protocol developers decided to do, is they said, okay, if you provide liquidity, we give you something additional, rewards. So this is the point in time where you can now say, okay, how much in liquidity mining rewards do I need to earn to even consider that this makes more sense than holding the items individually? So in order to allow you to consider this, let me provide you with an alternative version of calculating the impermanent loss, and that is with a single formula that covers the whole impermanent loss. So we are calling this the asset price multiplier. Is basically how much did the asset go up in value, how much X did you make. So 1X means it stayed the same, 2 means your asset double in price, 3, 4, 5. Yeah, so this basically is the indication of the impermanent losses. How much did the relation of one token to the other change? And by taking this into consideration, let's say 10x, 20x, 30x, 40x, 50x, or 100x, we can say how much impermanent loss are we incurring. So let's do this now. So let's say the impermanent loss, and I will now put in a single formula that does the calculation for you. I'm just copying this. You can derive this very slowly with a lot of explanations. I'm sparing these. This is the formula. If you want to copy it, just freeze the frame. And I can now fill this out for all of the positions here. And this is the impermanent loss we're incurring. We are now displaying this in percent so that it makes more sense. Yes. So if one of the assets goes 100x, you're incurring an impermanent loss of 80%. So how much earnings do you need to outperform this? This is fairly easy to calculate. So let's say you need an APR, or more precise would be an APY, but you need to understand what the terms mean. And yeah, there is not a lot of precision in crypto right now about how to use these terms. So let's call it APY, but you will make up your mind. So APY needed to outperform the impermanent loss. How much APY do we need? And this is fairly easy. So what we can do is, let's start here. So first of all, you start by saying, okay, we want to outperform a 5% loss. So what we want to outperform is basically that the value of this goes down by 6%, or that the position at the end is only worth 49%. And so we do this by saying 1 divided by the, no, 1, so the whole thing divided by 1. What am I doing wrong? Oh yeah, of course. So 1 divided by the whole thing. Yes, so you need to make an earning of 6%. So at the end, your position needs to be 1.06 times the size to compensate for the loss, or we just say -1 here. That is right. That is the right result. And so we apply this for all of our cells here. And this basically means that format number as percent. If your APY is 6%, in this case, you have outperformed the impermanent loss. If your APY is 25%, you have outperformed the impermanent loss of 20% or 4x. So now this gives you something very tangible in your hand. You know what APR, APY, depending on how you look at it, you need in case the ratio of two assets diverges by more than the factor 4 or 5 or whatever. So one last time, I'm letting you take a look at the formulas. This is the formula for impermanent loss. This is the formula for the APY needed to outperform the impermanent loss. And with those two, you can make much more informed decisions if you should even consider this. And in general, it shows you can solve a lot of questions by visiting a spreadsheet and thinking about how you tackle the problem and maybe find a formula, a more mathematical way to tackle the issue. I hope you enjoyed the video. If you like it, give me a like on Twitter, @EdisonBob. All the best to you. Goodbye.